Hello, welcome 3110 students. Today we are going to talk about closures under the topic of interpreters. So we're going to consider how we evaluate this code. So we declare a variable, then we declare a function that uses that variable, and then we reassign the variable we created earlier. Well, we don't really reassign it because it's functional programming, but it will change what it is in the environment, and then we actually call the function. So oh, and I just did this in Z just for completion, so this would be one complete expression. So our question is, what will be the value of Z after we evaluate this function that you see here? And as you can see, it will depend on what actual value Y will have under that evaluation. So we're going to use the big step environment model. This is a demonstration of that. So we will begin with an empty environment env and let e equal the entire above expression. So to evaluate e, we first need to evaluate this expression and the let expression under the semantics for evaluating let expressions. Recall those, we went over them before. And then, well, this is just an int, so we'll evaluate to itself. And then, by the semantics of let expressions, we will need to then assign y to have 5 in the environment, and we'll call this new environment env prime, and then we will need to evaluate the rest of our expression. So now we will have to evaluate this function definition right here. So let's just desugar f for a second. So we're going to rewrite f like this, and this is just to make it more clear that this is a function, and we're going to use this notation later on. So this definition of the function is inside of this let expression, and so we're winding up we are now, evaluating another let expression. These are all going to be let expressions because it's easy to program in OCaml that way. And so now we will evaluate the E1 of the let expression, which is just the expression that a variable is being assigned to. In this case, the variable is f because that is the name of the function. So we will first evaluate this expression for the function, and notice that this evaluates to what we call a closure. And a closure is the function itself, the anonymous function without its name, and the environment that that function was declared in, env prime. So, because this is a let expression, we now need to reassign, we now need to be able to look up f in the environment to find this function closure. And you'll see later why it will make sense why we use a closure instead of just capturing the anonymous function itself, that it will not actually be enough to just have the anonymous function. Because we are trying to achieve something we'll talk about later on, which is called lexical skill. But for now, keep in mind that we need both of these things for f in the environment. So env double prime will be everything in env prime, and also this new assignment of f to the closure. So now let us continue evaluating the rest of this expression, which is just these last two lines. So now we are going to reassign y again to 0. Sorry, we're not going to reassign again. We're just going to reassign, but this is OCaml, so yes, it's not actually reassigning anything because it's not mutable state. But so y will now have 0 in this new environment env triple prime. Keep that in mind that this is env triple prime where y is 0. And so now we will need to evaluate the last of our large expression, which was just the application of the function, essentially. So we have to find out what exactly this expression will evaluate to. We do not know yet. It is a mystery. So we will first evaluate each expression in the application, first the function, and remember we assigned f to be this closure, and env double prime and env triple prime has everything that env double prime has, except now y will be 0 instead of 5 as it was before. So keep that in mind, that in env triple prime it is 0. But f will evaluate to this closure, and 3, because it's just an integer, it's just a value, it will evaluate to itself, 3. So now we are going to evaluate this function application. But something very tricky is about to happen. So we evaluated f to be this closure, which had this environment in it from before when this function was declared. So when we evaluate this function application, we are now going to use env prime. Why? Because that was the environment in the closure. And this will be very important. So what will this be? Well, we first need to create the environments that we will evaluate this expression under. And what I mean is we will need to assign x to be what value it has. We need to assign the parameter to a value. And we do that by assigning it something in an environment. And so now we will evaluate this. We don't know what it is, so what is it? Well, y under env app, which is the new environment we created to evaluate the function closure, will have 5. And x in env app will have 3. Now notice what happened. Earlier we assigned y to 0, but that was in env triple prime, where y is 0. In env app, y is 5. Why? Because env app is just an extension of env prime. In env prime we assigned y to be 5, not 0. And env prime was what was in the closure, not env triple prime. We use env prime, we are using it to evaluate this function application. So now this expression becomes this after we evaluate each of these variables, and this will be 15, which means this whole thing will evaluate to 15, which means that this will evaluate to 15. So y was assigned to 0 before, remember. And if we had not used this closure, this expression would have evaluated to 0 because y would have been 0. But it wasn't 0 because we used the environment in the closure, which is very important. So z will evaluate to 15 because it is assigned to the result of this call, and we just ended the expression within z, so the whole expression will evaluate to 15. So this is what we call lexical scope. And lexical scope means that when you run the interpreter and you evaluate the definition of a function, you will use a closure to store both the function definition and the environment it was created under. If we had not done this, then we would be using something called dynamic scope. And under dynamic scope, this would have evaluated to 0. Most languages, they use lexical scope. Language designers like this because it reflects the idea of name irrelevance, because it would have mattered before what y was. We would have had to have considered that. We would have had to actually consider the body of the function when we use the function here. But we didn't really have to. We could just like call it. We would have had to, when we make this call here, we would have had to keep track of everything that y was assigned to understand what this would be. But we didn't because we used lexical scope, so we knew exactly what this function was, and it didn't really matter what y was because of the closure. So also, notice that if we had used, I'm not going to work this out now, but notice that if we had evaluated our expression under small step semantics, this first let expression, let y equals 5, it would have gone through the rest of the program and would have reassigned all instances of y to 5 in just that first step. And then it would have evaluated exactly the same as under lexical scope. We would have also gotten 15 under small step semantics. So this kind of further supports using lexical scope. So I hope this better clarified how closures worked, and I hope you enjoy the rest of your day.